Hello, everyone. Glad to have you back here. I have Dr. Adam Pease with me, and this is Viroo Mirji back to you after our last discussion on AI and ontology in healthcare. We are now back here to talk to you about more technical details on AI engineers, the developers, data scientists, and what are the problems or issues they're facing today. So with that, Dr. Adam Pease, a few words from you before I share the screen.
Yeah, thank you. Thank you for the opportunity to talk about this and to try to get a little more information out there on some topics, especially about data science that maybe aren't being covered as heavily as at least we think they should.
Exactly. So this is the topic for today. I'm going to go in slideshow mode. So I hope you can see the full screen. And it's really a focused topic, a discussion on issues faced by the AI engineers, the data scientists, any kind of developers involved in AI application development today. And Dr. Adam Pease has had more than 18, 19 years in this space, just focused on various areas of AI. I've spent a number of years consulting and providing solutions and full stack architecture for AI solutions out there. And here we're thinking about really what is impacting the developers. So, we've been in the field for quite some time now. We've asked data scientists, we've asked AI engineers, developers, we've heard various viewpoints from them. This is just a quick sampling of it. One of them could be something like, I'm being asked to do a lot in less time. Others talk about the development process or deployment process being too cumbersome for them. Others want simplicity while they are working on these kind of applications, AI-based applications. And then others want, like they don't want to deal with the data part, or they don't want to deal with the, the productionization part of it, which is really out of their typical scope. So, the common statement I've heard is, hey, I'm not a software engineer, I'm just a data scientist. And that's the issue that we're going to talk about today. We also looked at it from a different angle, which is, customer angle. If you empathize with our customers, they are also in a pickle because they don't have a COE to rely on, a center of excellence. They don't have the necessary skill set. They're still ramping up on AI skills. But they still have the business expectation, the need to have kind of the latest technologies, the latest serverless technologies, the production platform, which is completely monitored, well managed. They want a well architected framework or architecture. They want a dashboard, a documentation, which will be great for them, to help maintain the knowledge within the team. Even if some people leave the team, they can continue their product development or project work. And so there's a big gap we are seeing here between what the customer is expecting and needing based on time to market and the products that they're rolling out versus the developers, the data scientists, and AI engineers who are working in this field. And so today we want to talk about 5 primary topics or questions, and we can go through this one by one. Dr. Adam, if that's convenient for you, I'll just start with the first one, which is, what are some of the thoughts on issues or inconveniences faced by developers, data scientists, AI engineers today? What do you think is on their mind?
Yeah, well, I might even broaden this question a little bit. So recently I asked a colleague of mine who's actually not involved in artificial intelligence, but rather in data management and website automation for one of the largest retailers today. And I asked him about how do you manage your data? And what do you do with the challenges of getting everybody on the team to understand the data you have? And his response was consistent with what I've heard from many others, and also quite disheartening. His perspective was that there is a primary challenge about having developers understand each other's data. He manages a team that's several dozen people, so he's second level management. And the team naturally changes over time. The requirements that he's has to fulfill from management also change over time. He has to integrate different data sources, and this is a very common problem in machine learning. You don't just have one static, coherent data source from one point in time. And what do you do when the intended meaning of the data changes? And there's no way to record what that is other than maybe, if you're lucky, some comments.
Yeah.
This is a problem that transcends data science into software engineering generally. And I think it's underappreciated. And one of the reasons I was a little discouraged by my friend's response also was that he noted that everybody in his position is under so much pressure to just get functionality out the door that they actually don't have time to resolve this issue. If the issue is just sort of left to rest, if somebody misuses data, if the data meaning changes, okay, you get different analytics or you get bugs in the system and you handle that opportunistically when they come up. There isn't a sort of long-term strategy for addressing this problem. It's just treated as an inevitable part of development, and the cost of it is not being really addressed by senior management, and the first line managers and the developers are not really empowered to spend the time to solve this up front. So instead, they expend 10 times the effort later in terms of opportunistically addressing the problems that arise.
Yeah, some of my data scientist team members, they keep complaining that, hey, I'm going to face more data drift, as time goes by. As you rightly said, right? If the data is not structured correctly, if it's not designed correctly, if it is not linked appropriately to the right AI models and resources, if it's not used in the right way for training and testing and modeling and deploying out there in production with the right data set, you end up having lots of unexpected outcomes or things that you're not planned for. And it's primarily, in the data sciences community, I would say more of them are attributing it to data drift or concept drift, or maybe the model itself that they had in mind is now changing and shifting. So there's model drifting from the original purpose or vision. I also think some of the issues that are practical here are that they don't have the time. They're under such a big time pressure, and they feel like you rightly said, right? One of my data scientists in my team, he was saying that I'm going to spend most of my week cleaning up this data, balancing the data, figuring out ways how to use the right data sets for testing, for development, and for deployment and further validation. And so it's just like mind-boggling how much time is going in just getting the data ready. And then later on, even if you have the data ready, how do you keep that going, right? Time over time, as a new data sets come in, new models come in, new business issues are faced by those same applications that are present today. So I think the one is definitely the fact that there's less people available in the data science community, AI community, developer community. I've heard some friends of mine saying, hey, I wish I had 2 or 3 full stack developers and I had 2 or 3 data scientists available and they could all work harmoniously together, and it never happens, right? We've seen that. So just moving ahead from that, I think we need to go beyond that and kind of get true understanding of what's on their mind. Do they want tools which will make their lives easier? Do they want, what do they want which will allow them to solve some of these common problems and help the developer community overall? I'm just moving on to point number 2, as you can see here. So any thoughts initially there?
So the first step, I think, in solving a problem is to admit the problem exists. That was really the focus of your first question, of surfacing this issue and having the will to try to solve it, acknowledging the costs involved. Once that's acknowledged, then yes, how do we get a better understanding of the day-to-day needs of the data scientist with this problem front and center? How do we go about solving it? My approach has been to take the lessons from the software engineering community, that doing a little bit of extra work up front will save you time in the long run. So trying to sweep this problem under the rug and deal with it reactively rather than proactively is probably not the best solution. If we can do that, then we can start putting the tools and processes in place to address it. And I've spent a lot of my career doing exactly that, of trying to help people explain their data and add automation that allows them to capture in a very formal way what their fields actually mean, so that not only can they understand it, but they can be reminded of what they intended a year later, and new colleagues coming on the team have a clear and objective specification of what the data elements actually mean.
I'm seeing actually, two or three different ways, approaches people are taking to this in the world today. And I'm not saying anyone is bad or good, or the best, but I'm just saying that some people are approaching it from an angle that let's design everything correctly, like you said, right? Design and do the right structuring, the planning, all of that. The other option people are taking is the complete extreme opposite, and which is something I'm sure you don't like, but I'll bring it up anyway, Dr. Adam, which is they want to use auto ML. They just want to throw a bunch of data at auto ML and let the auto ML figure out for them which model is right, which data feature set has relevancy, and how they'll use it. And they just want to use auto ML, machine learning, as the only way forward because they think it's going to save them time. So that's option number 2. And option number 3 also could be a variant, which is, I won't spend as much time with design or the architecture. I won't spend as much time with auto ML, but I know my stuff and I will just pigeonhole myself in that, pick a small subset of data, and then I'll build an excellent model with 98%, 99% accuracy, and then I'll just deploy it in the world and everything will be hunky-dory, it will work well. We know, right? It never works out like that. The data is always evolving and changing. So any thoughts about this auto ML driven approach or the other approaches?
Well, there's nothing wrong with auto ML. I mean, that's a great approach if you have a high quality data set. But the algorithm doesn't work magic, rather. It can only work on the data that it sees. And so if you feed it inconsistent data, incoherent data, it's going to get an incoherent result. And we've certainly seen a lot of examples, headlines even over the years, of systems that have this problem. And it really comes down to that in a practical, problem that's not just something invented in a lab somewhere in academia, where you might have the luxury of having a smaller data set or generating your own data set. If your data actually comes from a number of different sources, not at one point in time, then you're bound to have this issue of data integration. If you have the issue of data integration and you haven't taken the time to ensure that the fields that you're merging together have coherent intent or definition behind them, then it doesn't really matter whether you have auto ML or any other sort of approach. Where it's not about necessarily selecting the right features from a set, right? Great, let the machine figure out which are the features that are the most indicative of particular outcomes. That's what we want. But they can only work on the data that they're provided. They can't work on the data that you don't provide, right? This should be sort of a fundamental thing to remember. You're creating a filter on reality, providing a certain picture to the machine of a portion of that reality. And it's a highly translated portion of reality. Not only is it a sort of narrow slice of reality, it's also distorted necessarily in many ways. Whether it comes to vision or financial data or health data, it's a long chain of transformations from the actual atoms in the real world to some sort of set of bits that this algorithm gets to operate on. And it's important to remember that there is this set of transformations. It's not just ground truth, it's a picture, an interpretation of the ground truth of the world. And that AutoML cannot work magic on data that it doesn't actually have. So there's no escaping this problem. AutoML doesn't even address this problem. The problem is, how do we get the right data into the machine? And one of the key aspects of achieving that goal is making sure that the engineers that are working on this data understand it, understand the intent of the data, and understand how to merge this data from different sources, where different sources not only also mean the same transformation path or sensor or input at a different time, when features of the environment and its interpretation may have changed.
Yes. Yeah, I think, the one thing I truly believe in the AI field, we do need AI architects. They are not well defined today. And, when people say, I want data scientists, they don't worry about the architecture. They're just worrying about the model. But we need the architecture focus. We need the design focus. And second point, I think this has been brought up by Stanford as well, the Stanford Computer Forum and, various human-centered design groups, that we need artificial intelligence, which is human-centered. We need human thinking. We need rational thinking, logical thinking, responsible AI, as we call it, right? Explainable AI, and all of these items. The reason it's really critical is because if we leave it to machines or we let it happen automatically, then we don't really have the true context. AI is not really meaningful if the context is not there, if the meaningful AI is not there, right? And I think that's where I'd like to move on to topic number 3 and 4 here.